Welcome to the DevGraph Tech Talk series. I'm your host, Aaron. Today, thanks to the miracle of video editing, we are going to deploy our very first container on AWS in just 5 minutes. Believe me though, it did take longer in real life. Containers, while amazingly powerful, there's a bit to understand in order to use them successfully. So I've got this Ruby on Rails application. It's a simple mastermind little web application. It's in GitHub. I want to run it on the cloud in a container. And I'm a moderately smart person, I want to think. Hold your laughter, please. So this should really be easy, right? I've got a bunch of AWS experience. I've worked in tech my entire life. However, I get started. I go to the AWS containers page, and what do I see? Lo and behold, a number of primitives staring me in the face. There's a registry ECR where the containers get stored. There's an orchestration layer. And of course, there's two options, ECS, which came out first, but then they decided that they needed to also support Kubernetes. So you've got EKS as well. And then this has to run on something, right? So you've got Fargate and EC2. Now, in this video, we're going to use ECS on Fargate. We'll take a look at the other options in another video. There's also a tool called Copilot, which AWS says makes this easier. Again, we'll look at that later. For now, we need to understand all of the primitives. So I went to ECS, and what's the first thing I realized? My application's not in a container. I have to create a container. None of those even let me do that yet. So let's look at the high-level plan. We're going to first create a container image from our application. We're going to store that in the registry, ECR in this case, and then we're going to run it on the hosted application or orchestration platform, ECS. So that's the high-level plan. However, there's a little more to it than that. So, and you can see these simple steps. So to create the container image, I'm going to use Docker to do that. So I installed Docker Desktop on my Mac, and then I clone my project so that I have the code. I use Docker build to create that image, and then I test it locally, Docker run, voila, brilliant, it works. Okay, now we're going to store that container in ECR. So you can actually get the Docker CLI to connect to the repository. You can get credentials from ECR, give that to the CLI. So first though, in ECR, we need to create the actual repository. Then the next step is to tag my Docker image locally I created, and then push that to the repository. Okay, now I'm actually ready to deploy it. ECS has this model of containers live within a task, live within a service, live within a cluster. So first we need to define the container and the task. That basically specifies how much memory and virtual CPU. At the task level, you can also share some resources such as volumes. The service then, that's where you can define load balancing, auto scaling, and then it goes within a cluster. And then finally, we'll test and make sure this thing works. All right, let's get started. So I'm going to browse over to the Docker webpage and download Docker Desktop for Mac. This lets you create container images and actually run them locally as well, which is pretty cool. Okay, so the next step, I'm going to clone my Git project. And this is, again, a simple web application. It's Rails app. It's on the Docker app branch. So I'll go ahead and do a fetch and then switch over to that branch. I'll show you the Docker file. It's pretty straightforward. It uses a Ruby base image, installs Node.js, does a bundle and a database migration. So pretty straightforward. To create the container image, you use Docker build, and we're going to tag it as mastermind 1.0. If we go into the Docker dashboard, we can see it there. There's our image. It's not in use. We don't have a container with it yet. Now we can run it though. We can also run it locally and map the localhost port 80 to the port 3000 that the container actually exposes. So there, we named it MM for mastermind. So there it is running. If we bring it up, here's our actual game. And it's a simple mastermind game. We're going to guess colors, red, green, blue. We'll get the last one wrong. We'll get the feedback that we got 3 right, and there we got the correct guess. So, okay, on to ECR. We can actually have the Docker CLI use this get login password. We can give that, and it can do the push for us. First, though, we need to use the create repository API, and we'll call it Darren's ECR repo. Here are the commands that we use to do the Docker tag. So we're tagging the image that's going to go into the remote repository, and then we push it. I did these steps earlier, but to show you here the Docker images, the one local, the one remote, same image ID. On to ECS. I tried to use their quick start wizard and I was sad it failed, I think because of the VPC. But let's do this by hand anyway. We're going to create a task definition and use Fargate for serverless. We have to give our task a name. I'm going to call everything Mastermind 2 just so it doesn't conflict with earlier stuff that I did. It needs to run as a role, so we choose the ECS role. And then you decide how much memory and CPU to give it. So I gave it a half a gig and basically a quarter of a CPU. For the container itself, we give that a name also. And then the image is a URL to our ECR repository. So we got that when we loaded our image into ECR. We specified port 3000. And then you specify the CPU and memory here also. It has to be less than what the task has so we don't overflow what we've been allocated. We'll skip all the other tags and everything. So we've got our task definition. Now out of this, we create a service for it. So again, we choose Fargate. We've got our task selected there. Again, we pick a name, so Mastermind 2 service, only one task. There's a whole bunch of other options here. We go on to the next step. So we're going to specify a VPC that's already existing. I'm going to choose both subnets. And then I already have a security group, which is pretty wide open. We'll just make it easy. So that opens up TCP. It's going to allow our port 3000. Load balancing. Okay, so I click load balancer, but I need to go to EC2 to create that, so I'll just skip that for now. We'll say none. We'll go on to the next step. Auto scaling, I can't really do because I don't have a load balancer, so here's all my reviewed stuff. There, I've got my service. That is completed. Now you'll notice it put it in a default cluster, so I don't even actually have to create the cluster this time, so it did save me that. There's my public IP. I got auto assigned, and voila, if I go to port 3000, here is our application. Whew, that took like 3 minutes of video time, but we did crush our 5-minute goal. I just want to say that. So under promise, over deliver. In real life, it took a few hours, but that's beside the point. Okay, but there has to be a better way to do this. So if you look at this stack, we were operating completely at the bottom level. AWS is essentially and primarily an infrastructure as a service. It has really powerful primitives that power much of the internet. But as we just saw, there can be a lot involved to getting containers right. Here's where Engine Yard comes into play. Engine Yard is a platform as a service. So we use the term no ops. Really very little effort spent on operations. We're going to automate and manage those deployments for you. And I'm going to show you that here in just a second so that you can focus on your container, your application itself, because that is what you really care about. Engine Yard is going to give you routing. It's going to do that port mapping for you, automatically provide load balancing, and automatically scale your application. Okay, so here is the process. Now, I show the git clone in the darker blue. That is the same step from before. You're still going to clone your project, but from here, the process is super simple. You create a cluster, which is a geographic region, and a VPC that your apps run in. Create your application, which maps to your Git repo, and then do a git push. That's literally all you have to do. So let's take a quick look. I'm sitting here in a directory where I've already cloned my project. And I can show you, I did have to make one change. So for the Docker file, the command is essentially ignored because the processes are going to be defined in a proc file. Also, the port's on 5000, so just so I don't get confused. And then here's the proc file. It's the exact same thing. We just moved that one statement from the Docker file command to our proc file. We've only got one component. You could have many components here. So let's browse over to the Engine Yard web console and we'll add a cluster. You can give it a descriptive name. I'll choose Darren's cluster, and then you choose the geographic region. Organization is the account you're in. You typically will only have one. Click Create Cluster, and you'll see the VPC and network information for this cluster. This is where your apps will run securely. So I can create my application by doing EYK create and then the application name. So I will call this Docker game. And what this does is it maps that project and creates a Git remote target. So now I've got an EYK. So now all I have to do is do git push EYK, and I am on a branch here. So let me show you that. I'm on the Docker app branch. So we'll specify that. So git push EYK, Docker app, and away we go. There you go. Now my application was deployed. I can use EYK open directly from this directory. That's going to open my browser, go to my web app, and hopefully we'll see our game deployed. And there it is. That was pretty simple, my friends. Okay, so we've walked through how to deploy your first container application, first natively on AWS using Elastic Container Service running on Fargate, and then we showed on EYK how that's a lot simpler. So AWS is great, extremely powerful primitives, but if you don't have an army of DevOps engineers, check out EYK. It's going to deploy your applications on a fully managed platform. We have best-in-class 24/7 support. All of this infrastructure on the left that you see is going to be completely taken care of for you. If you're in a very agile environment, you want to focus on your application, provide value to your customers, check us out, engineyard.com. Be sure to subscribe below. In future videos, we're going to also talk about Elastic Kubernetes Service, Copilot, and other things that were recently announced at reInvent. I'm your host, Aaron. Thank you again for joining us. We'll see you next time on the DevGraph Tech Talk series.